Okay, hello everyone. Today I am going to describe how to parallelize your code in Python. So for this demonstration, I will use a simple function which generates random numbers. And first I will define such a function that generates only single random numbers. Then I will parallelize that and put the output into a NumPy array. And finally, I will demonstrate how you can call this as, let's say, an external library or module. So let's get started. Let me first of all save my file and I will go ahead and name it as parallel underline example. So I am going to first of all import a few modules that I will be using. So the module I will be using for parallelization is called multiprocessing. And from this module, I will import a function called pool. So basically, this pool function defines a pool which is made up of several workers on your CPU and divides the task between these workers. The second thing that I have to import is my NumPy library, import NumPy as np, and that's pretty much it for the libraries. Now let's define a function. I will call it my underline random. And this function gets no input variable basically. I will just give it a dummy variable. And I will describe in a bit why I am defining this dummy variable. But for the time being, let's say we do define it. And this function returns as the output a random number, a single random number in the form of a float. So I will run np_random.rand. I will generate only one random number. This will give me a NumPy array in order to have only one float instead of an array. I will take the very first element of that array, which is a single element array. Then I will define another function, my_random_parallel. So this function does the same task as the previous one, but does that for generating a large number of random numbers. Let me call this total number as number of elements. And it does the job in parallel. So the way we do that in parallel in Python is using pool function that I mentioned earlier. So I have to define an object that holds this, let's say, pool function for me, the outcome of this pool function. And the output to this pool function is the number of workers that are going to be included in this myPool object. So usually your workstation or your laptop has 4 or 6 workers. You can assign a larger number. That's not going to be a problem. I will put, let's say, a number of 12. This number is very important when you want to not use all of the workers that you have on your machine. So if you have, for example, 20 workers and you want to only use 10 of them, you can put 10 here and leave the other 10 workers on your CPU alone, or let's say leave them aside for another task. Then I will go to my next line and generate a random array. My random array, I will call this. And I will do that using, again, NumPy arrays. We'll say NumPy dot. First, I will do the generation. So let's do the generation of a list of random numbers. So how that works is I will use my pool object and I will apply a method called map on it. So what this map does, let me finish writing it and I will describe it in a second. So it needs an input function. This is basically my input function, and then I have to say what is the iterable. The iterable I will generate it using the function range. I want to have this number of elements, so I will start from 1, go all the way to this plus 1. So let's take a look at this line of code and see what it does. So I defined a pool object. So this is basically an object that contains all of my workers in it. What this map method does is it maps this function that I defined as the first argument into all of the workers contained in my pool object. And let's say iterates over this, let's say, function call by the range provided here. Okay, the list of iterables that you provide here. And this division between workers is done automatically inside. You can also manipulate it and control how the work is being divided. But for the timing, let's go with the default option. Once I have this, the output is also a Python list. But since I'm working with NumPy arrays a lot, I would like to convert this into a NumPy array. And this is very easily done by saying, okay, convert my random array, which is a list, into a NumPy array by doing this by applying this NumPy array function. Okay, now I have my both functions. Now that I have it, let me define a number of elements. For example, I want to have, let's say, I don't know, 10,000, or let's say 9,999 random numbers. I just give a strange number just to have some fun, and then I have to write something like what I'm going to write in order to force this to work. So let me first write it, and I will describe what this piece of code does for you. Underscore underscore main underscore underscore. Then I will say, okay, my random array. Made a mistake here. Oh, I forgot the colon here. That is why it wasn't working properly. My random array is equal to, let me just change the name just to avoid confusion with this, although it's going to be fine. My random array generated, okay, is going to be my random parallel. So I'm going to call this function, and I will give it an input, the input being the number of elements. Let's say I will also change this name to avoid confusion, although it's going to be alright because the scope of this variable and this variable are local within this defined function. Well, anyway, so just to be on the safe side, let me just copy paste this, and voila. This is what I have. Let me run the code and see if it works, first of all, and I will describe this piece of code here. Okay, it works. And it gave me a NumPy array. You can open it up. I can simply double click on that. For some reason, I don't have anything in it. This is strange. So let me make this smaller and see if that's the problem is with that one. This is correct. Number of elements is also correct. My random is correct. This is name. Maybe the problem is here. Could be. Let me just fix this little thing over here. That could be the reason I am not getting this. No. Underscore main underscore. Let me run this again. See what I would get. Oh, I forgot to put the return here. So yes, this is the reason I was not getting anything. Okay, let's run this again. This time I have to get something. Yes, I did. This is one of the problems when you are doing a live demonstration, but this is okay. So this is a NumPy array with 999 random numbers in it. Now let me do a few small things, but before that let me describe what this line of code does. So what this does is it runs the code all the way down to here, and when the, let's say, running approaches this line, it says, okay, let me see if this Python script I'm running is the main script, is the one that is being called, let's say, run directly or not. And then, if that is the case, it goes ahead and runs the next line of code. On the other hand, if this is not the main one, for example, if this script is in the form of a module and it is being called, this line of code will not anymore be executed. So this is quite important, because if you don't put this line of code, it will for some reason not work. This is quite important. It takes some time for people not very familiar with Python programming to figure out why their parallel computations do not work. Now let's do some, let's say, variations. One of the important things that you come across frequently is sometimes the function that you are trying to parallelize is not written within the same file. So maybe it's an external function. Let me do that and see if that makes a difference or not. I'm going to go ahead and make a, let me define a new function, a new file. Let me create a new file and call this my random. Let me save it as my random worker function. So this is a random number generator that is being called as an external function. And it's nothing fancy. I'm going to just copy and paste this part of my code, import numpy as np, and the part that generates a random number here. And I will just save it, which I did by pressing Ctrl+S, and this is done. Now let me go back to my original code. If I want to use this function as something that is implemented externally, what I have to do is I have to call, let's say, import the file that contains that function. So let me go ahead and make this a comment to cancel having the definition here. Let me also import, what is the name of the file? My random worker, my random, oops, I did a mistake, my random worker function. This is a module. It quickly identifies the whole thing. So I will import this bit of module. I will import this module here, and instead of saying, okay, this is my function, I will say my function is my random worker function dot this. So it will go into this module and find this my random function and execute it from there. So this is also a possibility. Sometimes this function is a very big piece of work. You don't have it here. You don't want to copy paste it here. You just want to define a small function that parallelizes the call to this other function. This should be a possibility. So we just made a very small change here, and that's pretty much it. The next line is fine. It has to work now. Let me just change this to see if we get any difference. I want to generate, let's say, 9 random numbers in this case. Let's run it and see what we get. Okay, great. It works without giving any errors. So I have now a NumPy array with 9 random numbers, and this is by calling an external function. Okay, that's great. for the time being. Let's also try another possibility while we are at it. So let me just do one little thing to keep the generality of this code. I will go ahead and delete this bit and make this a comment. So you have both possibilities written in one script. That's nice and general. Let me demonstrate one more thing. But before doing that, let me also describe why I had this dummy variable before I forget again. So if you remember, in the definition of my single number generator function, I had a dummy variable. And I have to have a variable defined here, an input argument, because when you are trying to use the map function, you are providing an iterable which is going to be the input argument. If you don't have this dummy variable, even though this is dummy and there is no mention of that in the, let's say, mathematical operations I'm doing underneath here within the function, if I don't put this here, I will get an error because Python doesn't know what to do with this function because it doesn't accept any input arguments while you are providing here some input arguments that have to be fed into the function. So this is one thing. This situation usually does not happen, but you can, let's say, if this input, the iterable, is not going to be important in your calculations here, you can always define an additional input, call it iterable or a dummy variable, and pass it along and not use it in the calculations. Okay, let's take a quick look at the last thing I want to show you here, and that is what if my script here is going to be run as a module. So what will happen then? How do I do that? Let me define a new script. I'm going to call this give it a name. I will save this in the same directory. Let me call this parallel example module call. So this module call denotes that instead of having the parallel example run by itself, I'm going to call the parallel example module from another script, which is this one. So what I have to do here is basically I have to import my module. This time my module is parallel example. It has to show up. If I don't press anything, you see that parallel example is a module. We'll just double click on it. And in order to use this as a module, I just have to define a few simple things. So I just have to define the number of elements selected, which I will do here. I say, okay, let's say have, I don't know, 11 random numbers generated in parallel. And I will use exactly the same bit of code I had here down there. Very similar. But with one slight modification that I will describe right now. So this time, my random array generated is going to be the function my random parallel, but here it doesn't know the my random parallel. This is a function that is being called from my parallel example module. So I have to call it like this. So I will call the parallel example, my random parallel function from parallel example module. I will provide the input. Again, I have the same bit of code with name check to be main. This basically checks that this script that I'm running is the main one, and if that is the case, it will go ahead and run the next line of code. When I run this, what will happen is we are calling this parallel example module. It implements all of these lines of code all the way down to here, all right? And when it reaches here, it says, oh, this is not the main anymore, so this line of code will not be run anymore. Let's run this one and see what we will get. We have to anticipate 11 random numbers generated. So let me save this and run this and see what I get. Okay, this worked nicely. I got 11 random numbers, right? And everything is good. I have this. there I have these 11 random numbers. There is one thing that you may have noticed. So when I'm calling this module, it goes all the way down, and this bit is also run. But after this is run, the next line is not run. That is why I am getting 11 random numbers and not 9 random numbers. If this bit of code was being run, then I would get 9 random numbers. Let me just demonstrate this by quickly changing this name main to the name of the module I am running. Hopefully this will give me what I want to demonstrate. We'll run this. What I would anticipate here is after running this, okay, so this seems to be stuck because here it has this run and then it has also here, so it seems to be stuck. So I'm gonna go ahead and stop the kernel and restart it. So I can't do this demonstration like this. Well, what happens exactly when the let's say compiler reaches this line of code? It sees the name file being the same as the module name, and it will go ahead and run this. And at the same time, there is also this one that is being run. So this kind of glitch makes the spider not giving me anything as the output. So let me go ahead and undo this. Double check that everything is fine here. Let me make it like 4 random numbers. Hopefully this will work. Yes, it works. So this is pretty important. If you want to have this as main, you have to have this piece of code all the time in order to, let's say, run the code in parallel. This is just the take-home message I wanted to deliver here. Yeah, that's pretty much it. So one last thing, when you do run this as a module, again, we are defining this. It goes down all the way to here, and it reaches this point. Already the number of elements is taken as 4 that I defined before. Although this line of code is run, the output is already calculated with the number of elements I had before. And that is why I will get 4 random numbers and not 9 random numbers. A more elegant way maybe to do this thing is to use the this bit of code called try. Let me just make this into a comment and say, okay, I have try number of elements selected, and then I will say except it will accept name error, and it will give me this equal to none. So this is a more elegant way of doing this. So what this bit of code does is it checks whether this number is defined. If it is not defined, it will assign this value 9. So this way, if I am calling this function, it will never go below this variable, and the number of elements selected will remain as 4 everywhere. Even though when I was running this, as you see, the number of selected elements remains 4 because the variable explorer here shows the variables saved in this space, not the internal variables in the local, let's say, variable environment inside the module. But anyway, let's check this also and see if it works. It obviously works, and it will give me a NumPy array with 4 random numbers. So that's pretty much it. I hope you enjoyed watching this video, and I hope you find this video useful in your own work. Thank you very much.